HIV and AIDS by Anna Smith and Karina Guerra. HIV, or the human immunodeficiency virus, is a retrovirus and has two single strands of RNA. HIV is also considered to be a lentivirus or a slow virus, indicating that it takes a long time for serious symptoms to become revealed. An HIV virion is coated by a lipid envelope taken from the membrane of a human cell once the virus buds from it. The virus uses an enzyme called reverse transcriptase to turn its RNA to DNA within a host cell, which allows it to replicate itself using the host cell's machinery. Because it incorporates its genetic material with the genome of a host cell, HIV is also considered a provirus. As you can see, HIV is spherical in shape and has a diameter of 1/100,000th of a millimeter. The HIV replication cycle starts at number 1, with the fusion of the HIV cell to the host cell surface. Secondly, HIV RNA reverse transcriptase integrates and other viral proteins enter the host cell. At number 3, viral DNA is formed by reverse transcription. At the 4th step, viral DNA is transported across the nucleus and integrates into the host cell DNA. At number 5, new viral RNA is used as genomic RNA to make viral proteins. At the 6th step, new viral RNA and proteins move to the cell surface and a new immature HIV virus forms. And finally, the virus matures by protease, releasing individual HIV proteins. The disease is most prevalent in Africa. In fact, sub-Saharan Africa accounted for 70% of global HIV infections and 75% of all AIDS-related deaths in 2012. Right after Africa is Asia and the Pacific, where 5 million people live with HIV or AIDS, followed by Central and South America, where 1.5 million people live with HIV today. Today, more than 35 million people are living with HIV/AIDS worldwide. Mortality and infection rates have also continued to stay astonishingly high. In 2012, 1.6 million people died due to AIDS-related illnesses. Also, in 2012, an estimated 2.3 million people were newly affected with HIV. To put it in perspective, every day nearly 6,300 people contract HIV. That's roughly 262 individuals every hour. HIV is able to remain chronic, lifelong infection due to its ability to stay hidden within infected blood cells. These cellular reservoirs contain the genetic code of HIV, remain invisible to our body's immune defenses, and are not sensitive to anti-HIV drugs. Latent reservoirs of HIV are located throughout the body, including the brain, lymphoid tissue, bone marrow, and the genital tract. The most common modes of transmission include sex, drug injections, blood transfusions, and breastfeeding, but the risk of becoming infected exists anytime bodily fluids are exchanged, with the exception of activities such as kissing or sharing beverages. Some prevention techniques include not sharing needles when injecting drugs, screening for HIV when donating blood, not breastfeeding if you have AIDS, taking medicine at the start of the second trimester if your soon-to-be mother has HIV, and using a condom. HIV attacks the immune system by destroying CD-positive T cells, a type of white blood cell that is vital to fighting off infection. HIV is also known to damage the bone marrow and the thymus, which are needed in the development of precursor cells. HIV destroys CD4-positive T cells in multiple different ways. The first way is by killing the cell directly when a large number of the virus buds from the cell's surface, causing major disruptions on the membrane surface, leading to the cell's death. Another way the virus kills directly is when the virus excessively uses the cell's machinery for its own purposes, disrupting normal activities needed for the survival of the cell. The second way is through apoptosis, or cell suicide. If the virus excessively uses the cell's machinery, then the cell may decide to self-destruct or go through programmed cell death. A third way HIV damages T cells is when bystanding cells who may have some HIV attached to its surface are mistakenly identified to be infected and are killed by killer T cells, also known as CD8 T cells. And lastly, HIV destroys precursor cells, or young cells that later mature to have special immune functions. The destruction of these cells leaves people vulnerable to other infections, diseases, and other complications that are ultimately the cause of their death.
Two to 4 weeks after the contraction of the HIV virus, the body starts to show flu-like symptoms such as fever, rash, swollen lymph nodes, sore throat, muscle aches, mouth ulcers, and night sweats. Many people say that this feels like the worst flu ever. After this period, between 2 and 4 weeks of contraction, there can be a period of about 10 years, or sometimes more, in which the body of the infected person shows little or no symptoms, which is referred to as the chronic or latency phase. This means that the virus is less active in the body during this period, and some people do not even know that they have the disease because they don't show any symptoms. After this 10-year period, the count of CD4 positive T cells is generally low enough to identify the disease as AIDS. When the count of these CD4 positive T cells is below 220 per millimeter cubed of blood, the infected person has AIDS. Normal levels range from 500 to 1,000 per millimeter cubed. Once there are fewer than 220 CD4 positive T cells per millimeter cubed of blood, the body may start to show symptoms such as encephalitis and meningitis in the brain, retinitis in the eyes, pneumonia, tuberculosis, and tumors in the lungs, gastrointestinal effects such as chronic diarrhea and tumors, and skin tumors. There are many attempts by the immune system to prevent the growth and spreading of HIV by the infecting of other cells. The immune system sends out neutralizing antibodies which bind to HIV proteins and prevent their binding to T cells. There are 2 types of T cells, responsible either for helping the B cell to make antibodies or for the killing of damaged or different cells, which are considered to be all foreign cells except bacteria within the body. Also, killer T cells try to find and destroy the disease, but they are usually unsuccessful. Although these seem like they would work effectively to prevent the spreading of HIV, they aren't effective enough, so drugs are needed to prevent spreading. There are many drugs that can aid the immune system in preventing the spread of HIV on a large scale throughout the body. Although HIV is incurable so far, the symptoms are treatable. Most drugs used to treat the symptoms are inhibitors, which disable proteins needed for HIV replication. 2 examples of such inhibitors are abacavir and Zymogen, which are nucleoside reverse transcriptase inhibitors. Nucleoside reverse transcriptase inhibitors are faulty versions of building blocks that HIV needs to make copies of itself, which makes the HIV virus try to replicate, but fail without the viable parts needed to accomplish it. In 1981, AIDS was first discovered in young, gay, sexually active men in San Francisco. Because it first appeared in the eyes of the public among the gay population, it became known as gay cancer, which people thought was a rare form of pneumonia. Because of this, straight people thought that the disease wasn't possible to be passed to them and continued to have unprotected sex and pass the disease. Also, at this point, people didn't know that it could be transferred through the blood, so contaminated blood transfusions and unsterilized intravenous drugs continued to be used. In 1983, the United States Department of Public Health issued recommendations to prevent the spreading of this disease, such as practicing safe sex using a condom and not using contaminated needles and contaminated blood transfusions. 1 year later, in 1984, scientists discovered that HIV caused AIDS, and so more preventative measures were taken to limit the spreading of the disease. These worked in the US very well because by 1997, AIDS-related deaths had declined by 40% in the US from the time of its discovery. Sadly, in some other countries, the lack of education about what AIDS is and how to prevent it is causing it to continue to spread. HIV tests are the only real way to tell whether or not someone has the disease. By law, in the Affordable Care Act, insurance companies must offer HIV tests without a copay, so as long as you have insurance, you don't have to pay for an HIV test. Also, most medications are offered for free or very affordably because of insurance. Antibody screening tests test to see if there are HIV antibodies in the blood, urine, or saliva. If there are antibodies, then the person tested is HIV positive. But sometimes, if this test is given in the window between contraction of the disease and the time that antibodies are easily identifiable in the fluids, the test may yield a false negative result, so it is a good idea to wait a while between contraction and getting tested, so that the antibodies can build up in the blood and be picked up by the test. If you test positive for HIV, there are follow-up tests that are conducted to see how the virus progresses in the body and how many CD4 positive T cells are left in the body, in order to see if you have AIDS and predict which type of medicine would be the best fit for your situation. Even if someone has HIV, they can still have children. There are options for fertilization without sexual contact if only one parent is HIV positive, such as sperm washing. The father can send in sperms to be washed, and as long as the sperm washing is performed by a qualified medical personnel, it has been proven to prevent the spreading of HIV. Artificial insemination is an option too, so that if the mother has HIV, the father won't get it. If a woman with HIV becomes pregnant, she can take medicine beginning her second trimester at around 12 weeks that prevents the transfer of the virus to her child. This is almost always effective.
And finally, stay tuned for this public service announcement. For a future free of AIDS, there are 3 things we all can do. 1. Stay informed about the disease, new research, treatments, and prevention. 2. Be safe. Transmission can be reduced if we practice safe behaviors such as safe sex and getting tested. And 3. Spread the word. Maintaining awareness is crucial in understanding the disease and keeping others informed as well.